So the example number 6.8. So this is the problem based on our article. That is what we have discussed in motional electromotive force and energy considerations as a quantitative study. So इसका कंसेप्ट हम यहाँ इस्तेमाल करेंगे. तो आप ये देखिए कि जो डायग्राम है 6.12 उसको अपना ध्यान से देखना है. Here the arm PQ, this arm PQ of the rectangular conductor, डायग्राम किया हुआ है हमने. is moved from x is equal to 0. वो इधर से मूव करना शुरू करती है. It start moving from x is equal to 0 outward, इस डायरेक्शन में मूव करती है, in this direction. And the uniform magnetic field, so this is the dot, shows that its magnetic field is uniform to the plane and extends x is equal to 0 to x is equal to b. वो 0 से लेके पहले v तक आती है. And for x is greater than b, and then for x is greater than b. So only the arm PQ possesses the substantial resistance R. ये हम पहले डिस्कस कर चुके हैं. So consider the situation when the arm PQ is pulled outward. आप इस सिचुएशन को देखिए कि जब आप उसको x is equal to b से यहाँ आगे ले आते हैं. What will happen then? X is equal to 0 to x is equal to 2b, and then moved back to x is equal to 0. फिर आप फिर वापस x is equal to 0 की ओर ले जाते हैं with a constant speed. So the obtain the expressions for the flux. आपको flux के लिए expression निकालना है. You have to obtain the expression for flux. You have to explain the expression for induced EMF. You have to find the expression for force to pull the arms, and the power dissipated as joule heat, right? So sketch the variation of these quantities with the distance. और आप इन quantity का distance के साथ variation भी हम इसको दिखाएंगे कि किस तरीके से होगा. So to start with this discussion, to find हमें क्या क्या करना है. एक flux निकालना है. We have to find flux number 1. Okay, number 1. Number 2, you have to find flux. Number 2, you have to find induced EMF. Number 3, you have to find force. And number 4, you have to find the power dissipated at heat. Okay, और इसको दिखाना है. तो फ्लक्स का जो फार्मूला होता है, फ्लक्स होती है, फ्लक्स इज इक्वल टू फाई मैग्नेटिक फील्ड इज इक्वल टू बी डॉट ए, दैट इज इक्वल टू बी ए cos theta. So if theta is equal to 0 degree, you are left with b, and here it's having some length L, and breadth is x. So from 0, so flux होगा phi b is equal to VLX from 0 is less than equal to x is less than equal to b. And when you reach at this point, जब आप यहाँ से लेके यहाँ पहुँच जाएंगे, when x is definitely will become v, when x will become equal to b, here x is equal to b. So you will substitute x is equal to b. So flux at point b is equal to, b is less than equal to x and is less than equal to 2b. So this is BLB only. Now induced EMF कैसे निकलेगी? So induced EMF is equal to minus of d upon dt of phi b. So जब तक फ्लक्स चेंज होती रहेगी EMF होगी, जब फ्लक्स चेंज होना बंद हो जाएगी EMF नहीं होगी. सो आप देखिए जब आप इस पार्ट का डेरिवेटिव करेंगे, सो इस पार्ट का डेरिवेटिव करने के बाद क्या आ जाएगा, आपके पास आ जाएगा नेगेटिव ऑफ d upon dt of BLX. So here B is uniform, L is not changing because it remains inside the magnetic field, so it could be taken outside. It is minus of BL and then dx upon dt. So this is dx upon dt. So you can write it is equal to minus BLB. For what? For what? X is less than 0 is less than equal to B. And when x is equal to B, so then there is no change in flux because the change in x is equal to 0. At point B, when x is equal to B, जब x B हो जाता है तो dB upon dt is equal to 0. Then dB upon dt is equal to 0 because it will become constants. constant at that, and after that there is no magnetic field at all. So EMF will become 0 at this point, right? So now move ahead with this. When induced EMF is नॉन जीरो, जब induced EMF नॉन जीरो होगी तो करंट क्या होगा? करंट होगा I is equal to EMF upon R. You have done this. So EMF is equal to BLB upon R. All right. And then another parameter that is required for you to discuss about force required to keep the arms in constant motion is ILB. So its direction is to the left, is opposite to the direction of motion. यदि आपका जो rod है, यदि आपका जो rod है, if it is moving in the right hand towards the right hand side, then force is toward the left hand side. And when for the inward motion, when the rod will move toward the left, then force will be in the outward direction. It's opposite to the direction of motion of the rod. So force is equal to I. अब आप I का वैल्यू पुट कर दीजिए. I का वैल्यू आपके पास क्या है? I is equal to BLB upon R. I is equal to BLB upon R. So it will become B square L square. It is B square L square V upon R. Okay. So for 0 is less than x is less than equal to b, and it will become 0 for b is less than equal to x, because there is no current at all. There is no EMF at all, because in this region EMF is equal to 0. So EMF is the source of current. So I is equal to 0. So if I is equal to 0, then force is equal to 0 in that region. So then we will go for the Joule's heating loss. क्या होगा? Joule heating loss is given by the formula I square time R. So I का square यदि आप करेंगे, you will have B square L square V square upon R. This is force. This is not I. This is force now. This is only I. Okay. So this is a B square L square V square upon R for this region, and this is power dissipation is equal to 0, because the region, this is the region B से लेके 2B के बीच में करंट नहीं है. यदि करंट नहीं है तो पावर डिसिपेशन भी नहीं होगा. सो अब आप इसको डायग्राम में देख सकते हैं. इसका जो वेरिएशन है, जो चारों पैरामीटर जो है, जो फर्स्ट केस में क्या होगा, व्हेन 0 हियर x is equal to 0 and here x is equal to b and here x is equal to 2b. So now 0 to 2b and then 2b to b. So here this part is 2b and here is b and this is 0 once again. So इस रीजन में फ्लक्स क्या था वो आपने देखा कि this was BLX, this was BLX. और यहाँ जो जब ये V हो जाता है तो उसके बाद फ्लक्स चेंज नहीं होता है, because there is no field at all. So BLB here the flux will become maximum, and it will remain BLB, but the flux will not change, because x is equal to b. The flux will not change, and from here on, when you come back for the inward motion, so as x is decreasing, so the flux will start reducing, because area under the magnetic field will be less now, and it is regularly decreasing, so the flux is decreasing here in this case. And for the EMF, you have seen in the mathematics that we have done the mathematics related to it, that for this region this is equal to minus BLB, and when x will become equal to b, after that there is no change in flux, because if there is a see here from here to here the flux is constant, that is BLB. In this region flux is BLB. So if the flux is constant, there is no change in flux, then EMF is equal to 0 in this region. And when the rod is coming inward from x is equal to b to 0, x is equal to b to 0, what will happen then? Then the direction, according to Lenz's law, the direction of EMF is in such a way it opposes the change in flux. So it will now be in the opposite direction as it was earlier in the downward direction. Now it is in the upward direction. So the force is equal to देखिए पहले केस में, जब इस केस में, and this was the direction of velocity of the conductor from x is equal to 0 to x is equal to b, and then force is in the downward direction. is in the opposite direction, because when velocity is positive, then force is in in negative direction. So from here, x is equal to b now to x is equal to 0. So the motion of the rod is now towards this direction. So force is now, velocity is now towards this direction, then the force is now in the opposite direction. That is this by, this is having the magnitude v square L square v upon r. Okay. In third case, in case of power, so you know that if there is current, there is power. If there is no current, there is no power at all. So from 0, x is equal to 0 to x is equal to b, the power pj exists like this. And in these two regions, there is no current at all. This means there is no power dissipation. And from here to here, from this point to this point, then x is equal to 0, this current exists, so there exists the power. And this is all about this video. I think you can understand it in a better way. So thank you very much. I'm closing this video here on.